So we're given here that h of x is equal to 2x cubed minus 3x squared minus 3x plus 2. And we want to analyze and then sketch this function. Okay, so let's try first finding the x-intercepts. Okay, so when is h of x equal to 0? Well, if you use the rational root theorem, okay, you can find out that the possible values for the roots here are just going to be x is equal to negative 1, 1 over 2, and 2. Okay, so these are our possible x-intercepts. Now, for the y-intercept, if you plug in h of 0, right? If you plug in for x is equal to 0, you see how this term cancels to 0, this term becomes 0, this term becomes 0, and we're just left with this 2 over here. Okay, so the y-intercept is at 2. All right. Now, let's do the first derivative to find the critical values. So h prime of x is just equal to 2 times 3, right? Drop the power. And then we have x to the power of 3 minus 1, so we get 2. Minus 3 times drop the power, and then x to the power of 2 minus 1, which is 1. And then we get minus 3, and then the constant disappears. Now, if I simplify this a little bit, I can see that this is equal to 6x squared minus 6x minus 3. I can factor a 3 out to get 2x squared minus 2x minus 1. Okay? And then, using the quadratic formula, okay, we can find out that for when the first derivative is equal to 0, this only happens when x is equal to 1 plus or minus square root of 3 over 2. Okay? So this means, if I draw a number line over here, we have 1 plus square root of 3 over 2 here, and 1 minus square root of 3 over 2 here. Okay? And since the first derivative is just a simple parabola, I'm just going to draw it like so. So anything to the left of this root, it's going to be positive, so it's going to be increasing. Anything in between these two roots, it's going to be decreasing. And anything to the right of this root, it's going to be increasing. Okay, so we have our intervals of increasing and decreasing. Okay, and now let's find the second derivative here. Okay, so our second derivative, and before we continue, since it's going to be increasing in this region and then suddenly decreasing, we can say that when x is equal to 1 minus square root 3 over 2, right, if it increases, so our function here, I'm just going to move this 3 to the side, right, our function here is going to be something here, so this is our h of x, right, it's going to be increasing and then decreasing after this. So 1 minus root 3 over 2 is just a maximum. Okay, so this is a maximum value. And for x is equal to 1 plus root 3 over 2, right, our function h of x is going to be decreasing because it's in between the two regions over here. And then it's going to start increasing again. Okay, so this tells me that the value 1 plus root 3 over 2 is a minimum. Okay, so this is a minimum here. Now, for the second derivative, we have, using this equation here, it's going to just give us 6 times 2 times x and then minus 6. Okay, so I can factor the 6 out because they both have a 6 in common, so we can get 2x minus 1. Okay, so this tells me that when x is equal to 1/2, right, so on a number line it's going to look like this, and the second derivative is just a line, so I'm just going to cross this line through here. When it's to the left of 1/2, it's going to be negative, which means it's going to be concave down. Okay, and if anywhere to the right of 1/2, it's going to be positive, which means it's going to be a concave up. Okay, so when x is equal to 1/2, it is indeed a point of inflection. All right, so now let's start drawing this function over here using all the information we have. Okay, so we have our x-axis here, y-axis. Now let's use our first values here. Okay, so we know that it goes through the x-axis when x is equal to 2, so right over here, when x is equal to 1/2, which is right over here, and when x is equal to negative 1, which means right over here. Okay, so this 1/2 and 2. We also know that the y-intercept is at 2, which means it's going to be somewhere up here. All right, and we know that the value 1 minus root 3 over 2 Okay, so this is going to be a value that's negative, but slightly, so somewhere like over here, approximately. Okay, so it's going to be a maximum. Okay, so somewhere up here, it's going to give us a maximum, so that's the point in this direction. All right, and for the, so we did this value. Now for the 1 plus root 3 over 2. So that's going to be somewhere in between here. So I'm just going to draw it approximately here. Okay, that means somewhere down here will give us a minimum, which means it has to curve upwards like so. All right, and then finally, we know that to the left, right, to the left of 1/2, so to the left here, it's going to be concave down. Okay, so it's going to have to go through all these points, concave downwards like so, concave down again. But the moment we hit 1/2, right, it's going to be over here, it's going to be a concave up. Okay, so finally, we just connect the dots like so, and it goes upwards like this. Okay, so this is going to be our final graph.